This is pre-calculus, even though it says Algebra 2 right here, because we're reviewing Algebra 2. Here is our unit guide for, that's the actual Algebra 2 class. This is the Algebra 2 that we're reviewing. Here we are in 9-2. We're talking about special right triangles and coordinates. Notice that the homework tonight, we don't have any Khan Academy. Okay, I don't know how I should feel about that, but today is all a worksheet, and it's a short worksheet, just making sure you know your special right triangles. But let's go ahead and talk about where they even come from. So when a mama and dada love each other very much, when a triangle and square love each other very much, you create a ruler, you make a ruler drawing of a straight line, boom, right through the diagonals. Cut it in half. Cut it in half. And when you cut it in half, if you started with a square, you should have two triangles. And what types of triangles should I have? Right. In fact, they are two right triangles. And I want to make this one blue, because that way I can distinguish it from the setup. Yeah, so if I cut this in half, it is a right triangle. So let's go ahead and denote that, because it was a square. Rochelle got that right. What are the angles of a square? Plump, 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 plump. They're all
90 degrees.
90 degrees. But if I bisect that, it's a fancy way of saying cut in half, this is now 45. So this angle right here, label that 45 degrees. Label this one up here, also got cut in half. It is also bisected. So this one is also 45 degrees. Cool. There's our 45, 45, 90 triangle. That is one of the two special triangles that you need to know for the rest of your mathematical career. What's the other special right triangle?
30, 60.
30, 60, 90.
Oh, I hated that one.
And we need to discover that one from a triangle. Go ahead and cut it in half. How are we going to cut it in half?
Go from the vertex to the center, to the midpoint of the line opposite.
Yeah, good vocab. So that vertex at the top to the midpoint between the base angles, and you have a 90-degree angle because you cut it directly in half. An equilateral triangle that we started with, equilateral triangle by definition has all interior angles equal to what from geometry a while ago?
Sorry, would you mind saying that question?
An equilateral triangle, its interior angles, these angles right here, all of those interior angles were what by definition of an equilateral triangle?
Acute.
They are acute, but how many degrees?
Oh, 30, 60.
No, just an equilateral triangle. We haven't cut it in half yet.
Oh, they're each 60.
They're each 60. And the reason for that is because a triangle by default has 180. If they're equally divided by 3, because there's 3 angles here, 180 divided by 3 is 60. So all of them were 60. But when you cut it in half, this angle up here was 60. It's cut in half. It is now 30. Yeah, there it is. And because it went directly to the base, that is a 90-degree angle. So this is a 60, 30, 90, or a 30, 60, 90. That's where your special right triangles come from. Most people just start right away saying, say you have a 45, 45, 90, but they actually come from your basic geometric shapes. All right, let's do a little bit more review. And this is where you're going to have to draw a bunch of stuff.
No.
I apologize. Go ahead and draw that 45, 45, 90. Make it relatively large. I put dots on here, so it should. Yeah, go ahead and grab a ruler. This is 1, 2, 3, 4, 5. So this is going to be 1, 2, 3, 4. So come out like this and connect these. Don't grab him. Like that. Oh, that looks actually pretty nice. So this is going to be your 45, 45, 90 that you're drawing. So that's 45 degrees, 45 degrees. And also go ahead and just draw a standalone 30, 60, 90 as well while you're there. I'm going to give us some extra time to be doing that. I'm going to draw this one. It looks like it's about half, 1, 2.5, so I'm going to say 3-ish. And I'm going to move you right there. All right, there's my 30, 60, 90. I'm going to label him with my 60. Again, if it's a 30, 60, 90, the biggest angle that's not the right angle should be the 60. The other one should be 30. And there's our right angle. There is our right angle. I'm going to pause here until you get caught up. All right, so now that we have these triangles copied down, let's go ahead and title this. This is just another review. And this is a review of side lengths. All right, so on your review, if I say that this length is x, if I say that this length is x, what are the lengths of the other angles on this 45, 45, 90? Rochelle has an answer. Does Daisy know this?
Huh?
If this side length is x, then this side length is... All right, Rochelle, go for it.
X.
X. And what about the hard one, the diagonal?
Wasn't it like 2 times pi x? I mean pi, square root of x?
Close. You got the mix up. It's just x times the square root of 2. Yeah, there you go. Now you have it. It's in the notes. We'll remember it forever and ever. We'll think about it when we go to bed at night.
Not really.
You can lie and tell me that you will. Okay, so you will. Now we have the 30, 60, 90. This one is a little bit harder than the 45, 45, 90.
Okay, this one would be the square root of x, wouldn't it?
Nothing has square root of x on either of these guys.
Oh.
But try that diagonal. That diagonal does have a nice number, a nice easy number.
2 times x.
There it is, 2 times x, and the square root is going to happen over here. It's x square root of 3. Yeah, very nice. Good job, Rochelle. Write it down, Daisy. Daisy, you need to memorize
What?
this.
Yes, I did it already.
You did it? Okay. All right, so this is all review up to now. Now we're going to learn new things. Here's your new things. You have to draw this again. I apologize. I wish I would have done the setup here, but I didn't. The next class, I'll definitely have this down. But I want to grab all of you, copy and paste. I'm going to grab all of you, copy and paste. And I'm going to erase the side lengths. So I just want to draw the triangles without the side lengths on them. So get rid of that one, get rid of that one, and that one. All right, so you're redrawing the triangles. And once we get there, we also want to title this one new side lengths. And I'll wait for you here. All right, so we're back. So now what we're going to do is we're going to think about this in terms of a unit circle. So don't draw this. This is what you need to be visualizing in your head, though. Say this was my y-axis, this was my x-axis. I know. So that's my y-axis, that's my x-axis, and this point out here is on the unit circle. So this unit circle looks, okay, I mean, it's a bad unit circle.
Oh.
It's the worst I've ever drawn probably in my entire life. I can draw one that's slightly better.
Oh no!
It's the lag, I swear. See, it's lagging, and then I come back, and then anyway. There's a unit circle. Visualize it in your head. I can never draw a perfect circle. Doesn't exist in the real world anyway. Mathematicians know that a real perfect circle only exists in your imagination.
No.
Anyway, there's a unit circle happening here. This point is on the unit circle. Therefore, this length of the hypotenuse is what? Unit circle. Keyword, unit circle. That length of the hypotenuse is therefore the length of the radius, which is, yes, 1. This is a review from our notes yesterday. The radius of the circle is 1. Same thing if I look at this other triangle, and this one is also on the unit circle. This point would be a point on that circle. This would be the radius of that circle. That radius should also be 1, yes. So now we have this new triangle where the hypotenuse is 1. What we need to do in this class is figure out what these side lengths, these legs, should be.
You're going to have to go backwards.
We're going to have to go backwards. So we know from up here that in order to get from x squared root of 2 backwards to x, I needed to do what? Multiply, divide, something by square root of 2. To get from x square root of 2 back to x, what operation do I do?
You have to multiply with the power of 2. Or, well, that's
I can't take it to the power of 2 because then I'll be left with 2x squared like that. Try again.
you divide the square root of 2.
There it is. Yeah, you just divide by square root of 2. So go, and write this down in your notes. To get from here to here, we divided by the square root of 2. So knowing to get from the hypotenuse to the leg for 45, 45, 90, we just divide by the square root of 2. Then I come back over here. 1 divided by the square root of 2 will get me here. The problem with that,
You can't have square roots on the denominator.
yeah, you can't have square roots in the denominator. So we're going to write down 1 divided by the square root of 2 down here.
So it'd be square root of 2 over 2.
Close. You made a small math error, and that's why we're going to do it on paper. But I like how much you're trying. I appreciate it. It's really awesome that you're doing that. 1 divided by square root of 2. We need to rationalize the denominator. That's what it's called. And there's a funny poster on my wall about rationalizing denominators, if you can find it, but it is pretty funny. The reason why we do this is still not 100% clear to me. My idea about why this happened is because back in the day when we didn't have calculators, we had a giant book of what happens when you multiply by square root of 2. And we didn't want to lug around 2 of those books, one for multiplying, one for dividing by square root of 2. So we just learned how to rationalize denominators. Besides, it's a useful skill to know how to use to manipulate fractions.
Wait a minute. I was thinking about it. Wouldn't it be negative square root of 2 over 2? Because the way that you put it into the circle, it would have been a negative.
You're correct. Yeah, this would be a negative in the x-axis, right? This would be a positive off of the x-axis into the y-axis. You would be correct. Let's just go ahead and label this as if this was a geometric figure and we're talking about how long this length is. Yeah, but you're a step ahead of the game. So to rationalize the denominator, as Rochelle said, we're going to multiply this by square root of 2 over 2. When we do that, the daisy, you are going to get what on the numerator?
Huh?
The daisy, you're going to get 1 times square root of 2, which is 1 times square root of 2 is just one number, and it is
1.
nope,
2.
nope,
3.
nope.
4.
You're not. You
12.
passed it.
Square root of 2.
Yeah, there it is. Because 1 times anything is just that anything. And Rochelle, that denominator is going to be
2.
2, or square root of 4, right?
So I was right.
You said
I said
square root of 2 over square root of 2.
No, I said square root of 2 over 2.
I have video evidence.
Do it. Do it. Do it.
We'll go back and check it. Maybe I'm wrong. If I'm wrong, you get some extra credit. So coming back over.
Whoa. I have a question. Why is it 2 on the denominator?
Because it's square root of 4, and what's the square root of 4?
Oh, okay.
Yeah, so square root of 2 times square root of 2 is square root of 4, and square root of 4 is 2. All right, so that means that this length here, it was 1 over square root of 2, but the best way of writing this is square root of 2 over 2, which means
Ew.
this length over here of this triangle is also...
Square root of 2 over 2.
Yeah, there it is. Cool. So now we have this new triangle. This is going to be a homework problem, so make sure you know how to do this. We have the 45, 45, 90 worked out. This is the unit circle length. So if I had to label this, maybe an even better way of saying this instead of new is the unit circle. Instead of new, I'm going to also write above here unit circle. Because on the unit circle, this is what you need to know. And we're dealing with the unit circle for the rest of this unit. All right, we're going to do something similar over here. Let's go back to our original triangle. To get from, we're starting with our hypotenuse. To get from our hypotenuse to our leg, that's our smallest leg, daisy, what operation did we do? Similar to over here, where we had x squared root of 2 to get to x, we needed to divide by that square root of 2. So to go from that 2x to the x, we need to do what?
Divide by 2.
Divide by 2. So to get from 1 to this short leg, I need to divide by 2, as Daisy just said. So 1 divided by 2 is what, Daisy?
Huh?
1 divided by 2 is, just as a fraction?
1 over 2.
1 over 2, 1/2. All right, Daisy did that short leg. Rochelle, you're going to be doing the long leg. To get from x squared of, or sorry, we're starting with 2 times x. So we're going from 2 times x to x squared root of 3. A little bit harder.
Can't you just use the x and then just plug it
You
in?
could do that, yeah. So let's go ahead and do that. I think I accidentally did 1 over
So it's
2.
basically the square root of 3 over 2.
Yeah, so you're saying to get from x to x squared root of 3, you needed to multiply by square root of 3, which means to get from 1/2 to that other leg, I need to multiply by square root of 3, which is just square root of 3 over 2.
Your late mister already solved it.
I know. I had to make sure that everyone can see it, though. Daisy, you can see it now?
Yeah.
All right. We don't have to rationalize denominators in this one because we took the shortcut, which is actually doing 2 steps, but we don't have to do any rationalizing denominators by...
You're still doing 2 steps if you want that way.
I guess that's true. Yep. But you're doing the 2 steps all at once. So we understand how to get this, yes?
Yes.
So far so good. Let's flip over to the back, which is blank for you.
It's literally blank.
It's
doesn't have any
literally
numbers.
blank.
You know?
Nothing. That's because I printed it out on my printer, which has nothing. So you don't even have this. I always put moo there just because I need to change that in my notes. Anyway, so what I'm going to do now is the unit circle. Unit circle. And coordinate pairs.
Our notes are gonna be off, just tell you that.
I know. This is what happens when teachers don't plan coordinate pairs. You get less beautiful notes. But that's okay. You still have the notes.
Look up the graph.
It's okay. It'll work. Go ahead and grab a compass. Normally you wouldn't have to do this. I would have the circle already drawn for you, but you don't have a circle. So there's, I don't know if the plural of compasses is compasses or compassi, compi. No, it's probably compasses. Compasses, go grab them. They're by the 3-hole puncher. We need to make a giant circle. I have technology, so I can make a perfect circle. You don't have technology. I'm going to make mine blue. So make a circle that is big. Mega circle. Like
Thank you.
that big.
Ooh. The heck?
Sorry.
I hate
Right about there. Yeah, sure.
so much.
I don't like how they
So make a circle. Make it as big as possible.
Oh, hell yeah.
And then with your ruler, you're going to make a line that goes roughly through the center vertically. And I need to scroll down right there-ish. And I think vertically right there. Technically, it would go on and on forever because this you're drawing the x and y axis. This is a unit circle on the x and y axis. So let me grab this line, make him come out that direction. Let me grab this line. Grab. There you go. Come on. Don't move. There. Grab this line. Nice. It looks really nice. Really nice. Okay, so you have a giant circle and you have the x and y axis. You're good? You ready to go? Okay, what you're going to do is you're going to make a point. Maybe we should draw. Do we know how to use a compass? Sorry, a protractor?
Yeah.
We do know how to use a protractor? Okay, so now that you have your protractors, what you're going to do is you're going to lay your protractor so that it looks like this. Lay it right here so that the center is right on that origin.
Where? I found it.
And you're going to mark an angle somewhere out here that is 30 degrees. I'm going to have to estimate on mine because I don't have the technology set up quite yet. I would say 30 degrees is right about there on mine. And make a little point on the circle. You're going to do the same thing and make a 45-degree point. So I think 45 degrees on mine is going to look roughly right there. And then you're going to make a 60-degree point, which on mine I think is going to look, these should be equally spaced. So I'm going to just go like this and like that. Mine's a little bit off.
30 to 60 and what?
30, 45, and 60. I need to find the coordinate pairs of each of these points, and that kind of relates to our title, coordinates using special right triangles. We know what our special right triangles are. Let's use them on here. I'm going to do the first one with us, and then you can do them from there. So here's the first one. Go ahead and make a line, making lots of lines today, from this point to the origin. Because that now is your radius, and it is the hypotenuse of your triangle that you're about to make right now. So if I also make a line that goes, by the way, you always will make a line that goes to the x-axis. If you ever make a line that goes to the y-axis, you can still get it correct in terms of the answer, but the procedure is going to be a little bit messed up. So mathematically, you're fine. But procedurally, for my class, I would prefer you to always go to the x-axis. And it's one of those things where I kind of cringe at myself for saying that. I cringe because I'm making you do something the way that I want it to, even though could be mathematically correct the other way. But for the sake of just having everyone on the same page, go ahead and make this triangle. The hypotenuse goes to that 30-degree mark, and it goes straight down to the x-axis. It makes a right angle. So we'll even put like a little right angle mark here. All right, we have this picture, yes?
Yeah.
All right, I know that this length is what? This hypotenuse right here is what length? Nope,
1.
1. Why is it 1, Daisy?
Oh, is it because I forgot what I was going to say.
Give her time.
I don't even remember.
Okay, Rochelle.
Because of the unit?
Unit.
Of the
Circular.
circular?
It's a unit circle.
Oh.
And by the
Circle.
definition of a unit circle always has a radius of, Daisy?
1.
Yeah, that's why. So we know it's a unit circle, so this has to be a radius of 1, which is now the hypotenuse of the triangle by drawing a line straight to the x-axis. This height here we can figure out because we know what this angle here. I specifically told you, make sure that this angle is what? By construction, using your, well, not by construction, by using your protractor, you said that this angle was 30 degrees. Because we know this is a right angle, we know that it's a right angle because we dropped straight perpendicular to the x-axis, the closest point. If this is 30, this is 90, this also we know is what? 60, because they're 180 degrees in a triangle. Perfect. Now we know it's a 30, 60, 90. Hey, look at that. A 30, 60, 90, we know all the lengths of that because we just did it in the notes. Which means we know what this length is. And Daisy, you're going to be doing this one. Rochelle, you're going to be doing this length. Rochelle, you're doing the small length because you did the big length in the first problem. Daisy, you're doing the long length.
Sindel, take it slow for a second, all right?
So, Mr. Sindel, how long is this, Daisy?
Oh, Mr. Sindel, sorry.
How long is this? According to our notes up above, the long leg of a 30, 60, 90, the one opposite of the 60 degrees is?
Wait, which one are we talking about? I'm sorry.
So this length right here.
Oh, right there. Is it?
It's the long one. So which one of these is the long one?
Oh, it's. I am looking at my notes. I forgot what I was gonna say.
The long leg is how long?
The long leg.
Yeah.
Isn't it like?
It's one of these two.
I'm sorry. Oh, isn't it like? It's what is it called again? The square root.
Square root of?
3/2.
There it is. And Rochelle?
I couldn't think of it.
1/2, 1/2. Which means this is the part that I really care about. Well, I mean, I guess I really care about how you found it. But the answer that I don't care about as much as how you get it is the coordinate pair. The x-coordinate here is positive or negative. I'm going to the right, so it should be positive. Positive, square root of 3/2. Square root of 3 over 2.
Right.
And positive, because I'm going in the y direction, 1/2. So this coordinate pair is square root of 3/2 and 1/2. What I want you two to do, together or individually, it's up to you, is find the coordinate pair for this point and for this point. Once we do that, I'm going to come back and we're going to just guess where those 3 points are over here and do them over here, down here, and down here.
Wait, what?
Yep. So right now, don't worry about that for now. Find the coordinate pair of this point and that point. Then we'll come back. So you're going to make a triangle. You're going to draw a line straight to the x-axis. Find if it's a 45, 45, 90, 30, 60, 90, 60, 30, 90. Figure out what type of triangle it is. Use your notes up from above and label the coordinate pair. All right, so we're back near the end of class. I know notes were long because we took forever. By the way, on record, Rochelle was right. She got the extra credit. I was wrong. She did say square root of 2/2.
You're wrong.
I'm wrong, but I learned from my mistake. Everyone makes mistakes. All right, so this coordinate pair here is what? Who wants to do it?
It's square root of 2/2. Same thing.
Same thing. Square root of 2/2. And Rochelle, do the last one.
1/2.
1/2. So square root of 2. Square root of 2/2.
Like that?
Yes.
Ooh, mistake.
What the?
Square root of 3/2.
There it
Oh,
is.
sorry.
Ah!
Sorry. Hey, it says 3 here. Like, you want to see? Want to
But you
see?
said it
Yeah,
wrong.
it's misspeaking. That's fine. Okay, so be careful on the homework. On the homework, you're going to be doing all of these other ones. The problem with these is they have negative x coordinates. So for this one, I would get negative square root of 3 over 2, then 1/2. Down here in this third quadrant, everything is going to be negative. X and y. Over here, what's going to be negative? The x or the y in the fourth quadrant?
Oh,
Nope.
just a Y.
Just the y, yeah. So be careful on the homework for that. And that concludes the notes.